Good afternoon, everyone, and thank you very much for joining us today. My name is Nikhil Vaswani, and I'm a junior consultant at Turner & Townsend, and today we're kindly joined by Bhavik Daya, senior consultant at Turner & Townsend. This is a retrofit information, support, and expertise event, which is fully funded by the Department of Energy Security and Net Zero, and is delivered by Turner & Townsend. This will be a relatively short presentation, followed by plenty of chances for you to engage in a Q&A session with Bhavik. The event will be an hour long and we will finish on time. May I please request that you keep your microphones muted and cameras switched off during this presentation. The slide deck shared on screen will be made available after the event in a follow-up email to all attendees. Similarly, there'll be a clean recording of this and all other masterclasses in the resources section of the RISE website. Shortly, I will provide a series of useful links to our RISE resources in the chat function. May I request that any questions be posted in the chat function as we go along, or alternatively, should you prefer, you may come on screen to ask a question directly after Bhavik's presentation. Finally, there will be a quick poll and word cloud at the end of the session. May I please ask that you complete these as it helps us understand the level of knowledge across our topics. And with that, I'd like to thank everyone once again for joining, and I will pass it over to Bhavik to start today's presentation on planning retrofit interventions and cost caps. Over to you, Bhavik. Thank you.
Super. Thanks, Nikhil. Yes, welcome everyone to this masterclass session from the RISE service. As Nikhil's mentioned, I'm Bhavik Daya, Senior Sustainability Consultant here at Turner & Townsend, and I will be taking you through this session, the agenda for which is as follows. So we'll be looking at aspects of why do you need to plan for retrofit, so like why is it important, what goes around that, some of the key principles that are included around retrofit, understanding stock analysis and how that's beneficial for the whole process. We'll also look at the cost cap consideration, so based on the Warm Homes Social Housing Fund as well as local grant, what to consider in terms of those cost caps that exists. Then also looking at deciding target outcomes as an organization, how that's important and how that ties into planning for your retrofit interventions. That also then ties in with identifying target properties. How does preliminary design impact that, along with retrofit assessment? So yeah, just an overview of Warm Homes. So as you may have come across, there's an overall Warm Homes plan to upgrade 5 million homes across the UK. And there's obviously that links to a performance target of at least reaching EPC band C in homes that are treated. There's a UK-wide net zero target by 2050, as well as along with that trying to alleviate or make a lot of progress towards reduction in fuel poverty by 2030. So as mentioned, there are two schemes largely, which some of you may be familiar with under previous names of Social Housing Decarbonization Fund and the Home Upgrade Grant. So the funds, as we know them now, are both termed the Warm Homes Funds, and then the one is the local grant, and then the other one is Warm Homes Social Housing Fund, both of which are social government-funded schemes, and they aim to target low-income households and social homes. These will be delivered by local authorities, combined authorities, registered providers, and so on, depending on the stock that's in question. And properties that are eligible are those that are rated between D and G, and ultimately it's to support the transition to low carbon heating and upgrading the energy performance of these properties. So why do we need to plan for retrofit? So there are many instances to consider around this. Some of this being that properties are unique, so it's not a one size fits all. There are lots of different archetypes. different residents with different needs. So these are all aspects that we need to look at and consider. And all of this brings different costs to it. So in terms of the retrofit measures, some require different design solutions, which could mean different contractors are needed. So there's also a need for including this in your planning and mobilization to understand, oh, do we need different contractors? Do we need to allow time for that through our procurement process so that we have everyone on board? So that's quite essential in the whole planning process of how you're going to go about retrofit. And ultimately, that's for achieving some efficient delivery. So if you plan for your retrofit, you can foresee challenges through risks assessments and allow for more effective delivery, and basically be able to avoid any issues on that front. So yeah, planning starts with having the right data so that you can have that accurate data to determine what efficiency measures are needed for that particular home or particular types of properties to achieve a target. And yeah, the last thing anyone wants is to have measures or the wrong measures installed, which result in damp and mold. Sorry, I just want to switch on a light here. Yeah, so the last thing you would want is dampened mold that creates extra costs that you then need to go back and fix. So yeah, planning for retrofit in that sense is quite important. Retrofit key principles. So many of you would be quite familiar with the fabric first approach. So as the name suggests, it's looking to tackle the fabric of the building or the structure as the first instance. So these could be the likes of upgrading wall insulation, so whether that's EWI, external wall insulation, or CWI, cavity wall insulation. So getting a better thermal envelope on that front. And the other two aspects of what's exposed is your roof and wall, so insulation in those two areas, loft insulation or actual roof insulation, and then underfloor insulation, which can be more tricky. And then there's obviously upgrading doors and windows, because that's also part of your fabric first approach, and trying to seal off any gaps that occur there. One thing to always keep in mind is that when you go for that fabric first approach and you make your building more airtight, you need to also consider the ventilation need that comes along with it. Then the second part that's quite important is the whole house approach, and considering how you tackle the whole property and not just one element. So yeah, this is not always the easiest thing to do because the cost to escalate, but trying to have a whole house approach of how you're going to go about it, or at least tackling elements that are related to each other. So if you are doing EWI, you do doors and windows at the same time because those elements interact with each other. So yeah, step one, as we mentioned on the fabric first approach, is about reducing heat loss. So yeah, typical interventions for cutting heat loss are that occur through the fabric are around the walls, so insulation on the walls, and as we can see, generally about 35% of heat loss occurs through uninsulated walls, and that's what makes up the largest area of any building. So if we're able to tackle that, that goes a long way in reducing heat loss and making a more thermally efficient envelope for the building. The same goes for the roof. 25% of heat tends to be lost through uninsulated roofs. So having loft insulation installed, or if it's a pitched roof, you can have roof installed on the pitched roof itself. And that obviously determines whether you want to have a cold loft space or not. And then there's certain aspects to take into account. insulating doors and windows. 10% to 15% of heat gets lost through those elements. And then, yeah, overall air tightness is quite important. So draft proofing, installing air tightness tape around windows and doors, and any air tightness membrane, especially around joints where you have your roofs and walls intersecting and so on. Step 2 of the process is then to decarbonize both your heating and your hot water supply. So yeah, once you've managed to reduce the demand of heat in the building through the fabric first approach, you get to a place where the heating requirement for the building is reduced substantially. And this provides you just with a better option of then going to a low carbon heating source instead of having upgraded or installed a low carbon heating source that's aligned to what your current heating demand is. Because once you do get to undertaking some fabric improvements, your reduced demand means you could end up with an oversized plant or heat pump or whatever it is, where you could have saved costs by installing a smaller unit. So yeah, evaluating the options for low carbon heating. This could be the likes of installing a heat pump, as we can see in the picture on the top of the slide. That's the external element of the heat pump. So something to be considered is, where does this go? Is there space for the element, and is there any planning or conservation aspects around it? Connecting to a low carbon network. These are slowly starting to become more and more prevalent in the UK, and there is elements within the guidance that speaks to this. So it's always good to have discussions with your local councils and the anyone in that region that would be undertaking work around a low carbon network, understanding the timelines of that coming on board, and if there's any upgrades that you can plan for to coincide with such. So solar thermal heating for hot water. This is also quite useful. So instead of solar PV, you're just going to use solar thermal to heat the liquid. This actually needs storage tanks, so sizing and space requirement is something to consider in this aspect. And then, yeah, where renewable sources or heat pumps or the like are not possible, then there's always the likes of highly efficient electric heating or high retention or high heat retention storage heaters, as we have in the picture on the bottom right hand side. So those are, yeah, call it your worst case scenario of what you can do if none of the other instances are possible. There's also the likes of radiative ceiling panels, which are becoming more and more popular. So it's always good to understand what those options are and if they would work in your solution, in your proposed solution. It's always also important to make sure that any measures that are installed under these schemes are Trustmark accredited, and the installers have the necessary certifications. Moving on to stock analysis quickly. So yeah, this step is all about understanding your housing stock and how this goes into then your plans for retrofitting and understanding the cost caps. So knowing what construction type all your buildings are, knowing where they're located, the condition that they're in when certain things are to be replaced on them, and how that ties into any plans that you have for energy efficiency retrofit. So for instance, do you have to replace the roof in a certain year? If you are going to be doing that, that's probably the best time to do the other works. You're going to have scaffolding up, you can do the EWI, you can put in the new roof, and while you're putting in that new roof, you can install the necessary roof insulation and so on, because you wouldn't want to have installed roof insulation into a bad roof that might be leaking. That insulation will just get damaged, and in time when you actually get to replacing that roof, you have to replace the insulation again. Knowing the current energy levels or energy efficiency levels, the EPC ratings basically of properties, allows you to then target which ones to go for first. Knowing the residents, do you have vulnerable residents in certain areas? Are there certain instances that certain residents, certain times of the year or certain dates don't work for them? Are there families where undertaking works over the summer break when kids are at home could be difficult? So planning all of that into the interventions that you're going to do and your project plan is quite important. And also just knowing when have you recently done work on the property? What was the interaction with the customers? Are you able to keep a record of that type of information? So just knowing which properties you can get into easily or have good relationships with the customers, or knowing which properties might be a bit more tricky and focusing enough time in your program to deal with that. And then also what type of heating system is there? Is it a wet heating system? If you are going to do an air source heat pump, is there a requirement to upgrade the radiators and so on? And just understanding how that works across your stock allows you to plan better and bring those cost elements into the planning aspect. So there's just some examples of stock analysis, and there's various softwares that can do this. Could just be using an Excel spreadsheet that just tracks all of this data, and you can pull out some charts from your Excel data. So yeah, as we can see here, you can easily identify how many solid brick walls are within this portfolio of properties, how many cavity walls. So that gives you a quick idea of which ones to target, and those can then be linked to an EPC. So you'd know how many EPC D and below properties you have that are solid brick. So you understand, okay, likelihood is we can probably go for EWI on a lot of these properties as a first instance, and make that part of your planning solution. Geospatial and investment scenarios, understanding the spend profile of how much you need to spend and where, and the geographical areas also helps in your planning, especially if you have more than one contractor. You could have them focused in different areas, or you can try and focus on an area where you have a lot of properties first and then try and do the more difficult or pepper potted locations, or do it the other way around, focus on the pepper potted first, and then towards the end you can then focus on a specific area and just push it all out. All depends on the relationship with the contractor and how well the contractor knows the area and how mature you are in delivery, which method you would want to go for. So just in terms of cost cap considerations, so for Warm Home Social Housing Fund, there's a base cost cap, which is a maximum of £7,500 in terms of the energy efficiency upgrades. And then there's also a more minimum co-funding requirement, which needs to then match up that maximum 7.5. So basically per home, what you would have is 15,000. For off gas grid low carbon heating, there is an additional 7.5 in terms of grant funding. So that's to upgrade off gas grid properties to low carbon solutions. Then there are properties that are on gas grid, which you would be looking to move off the gas grid and onto low carbon heating. So this is a bit more nuanced, and it's only up to 10% of the homes in the application that can be considered for this. And for that, there's a 20,000 allowance per property, but this is not in addition to the base 7.5 thousand. It's just a standalone 20,000, and for this there's no minimum co-funding requirement. In terms of Warm Homes local grant, so the cost cap considerations here is that there is £15,000 associated with energy performance, so basically your fabric first type of measures, whereas low carbon heat has the same associated amount, 15K, and that again is then to anything that's low carbon heating. And within the guidance, there's a list of measures that fall under each of these. So just a note here, where home is owner occupied, so a private homeowner that resides in the property. In that case, the upgrade should be fully funded by the local authority or council that's received the funding, and the household's not required or must not be required to contribute to the costs of the upgrade in the property in any way. So yeah, just looking at this in a little bit more detail for the private rented sector and the eligibility. So where there is a landlord that has multiple properties within the local area and satisfies all the eligibility requirements. For their first property, there's no requirement for the landlord to contribute for any upgrades, and the cost caps are as mentioned before, so the total of 30,000 spread equally to energy efficiency and low carbon heating. In terms of a second property, then the maximum grant funding in that instance is 15,000 in total, split equally 7.5 for low carbon heating and energy efficiency. And in that instance, there is a required contribution from the landlord of match funding. Yeah, we've pretty much covered this, but yeah, the maximum required social housing landlord contribution is then to match up with what the grant funding is. So just back onto the planning retrofit interventions aspect and deciding target outcomes. So what is useful to be aware of when you're going about this is once you have some stock analysis that's taken place, it's time to kind of decide what are the outcomes of the retrofit project that you're after. So this typically is around achieving EPCCs by a certain date. You could maybe even say certain area or certain homes are to be taken off the gas grid or moved to low carbon heating. You might have a gas boiler upgrade or gas boilers moving on to air source heat pumps in a certain area, or install a solar PV. And this could be targeted by certain areas, certain number of homes, by certain dates. And having this overall plan of retrofit then assists in what you do when there's funding available. So yeah, just some of the cost cap considerations. So there's the base cost cap of 7,500. This is more in terms of the social housing fund. So yeah, understanding that applicants are required to co-fund that same amount. So knowing what you have in your budgets towards your retrofit plans can then help you establish how many homes you can tackle and how much grant you can then apply for. Then there's obviously the uplift for off-gas homes. So alongside the base cost cap, the 15,000 for taking the total funding to 15,000 in terms of upgrades of low carbon heat. And then when it's on gas grid, if you're going to use that 10% threshold to try and then move those homes totally off the gas grid, where there's no co-funding requirement. Identifying target properties. So this ties in with the previous section that we've just mentioned of knowing what it is that you want to do with your stock overall, and identifying what type of properties exist. So knowing the different archetypes, is there almost a little bit of a generic solution that you can use for a certain type of archetype in your planning, knowing, okay, for this type of property, we have X amount of them, and generally we will spend this amount of money, and these are the 2, 3, 5 measures that are generally suitable to that property. And that allows you to then plan and target how you will go about the properties, because you also have a view of what timeframes you can work to, how long it will take to go through the properties. And also sometimes useful if you haven't worked through such a retrofit scheme before, to try and see if there's a way of having discussions with potential contractors to understand from their view what they believe their capabilities are in helping you deliver, or if you have delivered before and you do have established relationship with your contractor, they would most likely be quite happy to share some insight into helping you plan with the timelines and so on. So yeah, just identifying a portfolio, a subset in the portfolio that is selected for certain aspects of the funding. And it might be, if you have a larger project, that you also break down your delivery planning based on certain archetypes. So you might have, call it, schemes within your overall project of delivering a certain archetype or certain geographical area together, and that's how you move through your project. And it's a better way of you also being able to track progress overall. In terms of preliminary design, so it's always very important, once you've defined your target outcomes, to select a set of properties for the project. Next step would be to think about a general approach to maybe software modeling for that preliminary design. So this could include like compiling all the existing data, assembling the right team in terms of designers, retrofit coordinators, and so on. And then also considering the ease of access. And this is especially in relation to the properties themselves. So this could mean that you might have within your assets team, they undertake condition surveys of your stock anyway. And in that, is there a benefit to maybe upskilling those individuals to be able to undertake some retrofit assessments as well. So when they are accessing the property, they can do the condition survey as well as the retrofit assessment. So you're kind of having a single access to the property, not needing to go in multiple times, especially where it might be difficult to get access to properties. So yeah, understanding and planning for that, or seeing where you might have rejection in getting into properties or access issues, is quite important in the preliminary design phase. So yeah, what to be aware of when you're going through this phase is to consider the project budget and the funding. So how much do you have in terms of co-funding? How much are you going to be applying for in terms of the grant funding, and checking your objectives and the intended outcomes of the program. Are you going to achieve the required minimum EPCC by implementing the measures that you are considering? Are the properties that you are looking at, are they eligible? Or is there a chance that you will need to swap out these properties? And do you have any like reserve properties that you can consider? Establishing whether software models that you've used comply with the requirements. And there's obviously different changes that are occurring in terms of that front. So it's always important to keep on top of that. And yeah, also thinking about the potential contractors and ongoing maintenance needs that are related to these type of elements. A small example could be in terms of EWI, for instance, if you're undertaking that type of work, ensuring that through the process, the residents know that, oh yes, once this is done, they can't simply just drill into the EWI and put up their post box again or their flower basket. There's certain aspects that they need to go through, and that's all managed so that you don't then need to go back and rectify that. The risk assessment element. So yeah, just looking at that aspect. So in terms of assessment proportion, so the assessment risks that you could have, potentially having the wrong assessor undertaking the work, or assessor that's not looking at all the information that's available, so understanding the competencies there. Inaccurate assessment also linked to that proportion, wrong measures. It could be that they are looking at similar archetypes and not considering that exact property. So sometimes there is a need to have a deeper dive into the property itself to understand if the measures that are being proposed are correct. And then, yeah, is it optimistic in terms of the fuel savings that are being calculated? And the mitigation around this is not always so straightforward, but it's quite important that then within your teams, upskilling members to go through some of the retrofit training, having a view of a rough idea of like, okay, these specific measures, this should be the outcome of it. This is type of measures that work on these properties and don't work on these type of properties, or this is where we've seen issues before. And then, yeah, just going through that triage assessments or whatever you've been provided by your retrofit designers and assessors, coordinators, as well as the contractors, depending on how the relationship is set out, that you are questioning what's being shown there and asking questions around it. So yeah, going through that training and certification is quite important. And also if you're using any assessment software, just understanding how the software works and what it's showing you is quite important. In the design stage, we have some of the similar type of risks. So poor retrofit strategy is not being is implementing your strategy. Is the design linked to that, or is there no retrofit strategy that's helping advise which way that the retrofit design should be moving? Poor integration of measures, so there might be multiple measures that you are undertaking on a property. Are they being done in a sense that they work together? So like we mentioned earlier, if you're undertaking EWI, the likelihood is that you'd want to do doors and windows at the same time, especially if you're looking at the data associated with that property, and you know that in 2-3 years time, the doors and windows for that property are reaching their end of life and need to be replaced anyway. You build that into your planning and your overall strategy to say, yes, we need to make sure when we undertake this EWI, we are doing these other things as well, because it's something that's in our horizon. Overheating, this is something that is often a problem that occurs. So your design is going to make your building more airtight. You're going to have double glazing, so where there is a lot of solar heat gain coming into the building with no cooling in the building, you could end up with overheating. So do you have the ability to air out, or is there adequate shading that's been incorporated into the design where needed, and is the ventilation suitable for that? Poor communication, and this could have a variety of instances where this could occur. Is it with the contractor and yourselves as the client in terms of what needs to be achieved, or it could be in terms of the resident that's receiving the measures. So yeah, making sure that whatever is communicated is done so timelessly is quite important. So yeah, as we see here in terms of mitigations, the fabric first approach is always a key thing in the design. So making sure that you're not undertaking low carbon heating in the first instance, which could be oversized because you haven't considered the fabric first approach. Communicating clearly with residents what it is, and if it's a case of measures are not fully decided, making sure nothing's overpromised before those are finally signed off. So understanding how to communicate what's going to be happening to a property is quite crucial. In terms of the installation, so yeah, poor integration is something that can definitely occur. So if it's a case of having a EWI installed and not extending roof eaves, for instance, those two are not being integrated well, you're going to have an issue with what you've installed. and you're going to have an issue there. Inappropriate substitution, so you can't just pull out a gas boiler and put in an air source heat pump. You need to consider if the radiators and so on are sized appropriately, and is it all going to work, and also is the resident going to be able to utilize everything and understand how the new kit works. And then, yeah, poor installer design. So the design element coming to the installer is quite important, and having all of that incorporated. And then also commissioning points. Commissioning can be a problem where you don't know if once everything is done, if it's all been signed off correctly and been checked adequately for its compatibility and suitability. So yeah, the mitigation for this is having multi-skill teams, as mentioned, having people within your team that have the ability to give some oversight, go out to site, and almost undertake that QA role for yourselves, or you might have a independent contractor appointed for that if you don't have that in-house. Change management control. So if there is something that needs to be altered from design stage to installation stage, making sure that that's properly recorded. It might impact what you have in terms of grant funding, and if there's certain measures that need to go through a change control on that side. So it's quite important to make sure that what you have set out in your initial application kind of ties in with what you are saying you're going to do, and that it achieves the same objectives. And detailed design of services is quite important, especially where there's numerous things going on in the property. Avoiding any clashes of services, and making sure that once the installation team is on site, they can go ahead with installation and kind of minimize any problems being only realized on site. And this is something that becomes a learning process through it. So once you've established an issue on a first property, making sure that doesn't get replicated again. And then finally, commissioning, really important, making sure that everything that's been installed is commissioned, working properly, the necessary tests and checks have been done, and that's recorded, and all of that information is then passed on to the relevant people. And then finally, in the operational stage, so operational consequences, if any of this is not done correctly, or there's issues, you can have condensation and mold occurring. You could have controls not used correctly, so you might have installed an air source heat pump and people think, oh, I need to switch this off when I'm not using it. Meanwhile, it's a device that needs to stay on the whole time, and it will put itself into a standby mode if it needs to, and will kick in when it needs to. But if you're just switching it on like a gas boiler, the moment I need hot water, it's not going to work because it needs a lot of time to heat up. So understanding that and showing those type of things to residents quite useful. Systems being disabled and overridden, similar thing. Users just knowing that they shouldn't change any settings, or what settings they can change, or how that all goes around. And then, yeah, just overall poor energy performance. So if the design and installation is not done according to what needs to be done, you're just going to end up with a property that's not performing as designed. So the mitigation, having handover procedure to the residents and to yourselves to understand what needs to happen. Samples of post-retrofit testing to check against design criteria and design objectives. Has this been met? Is the property achieving the required level of heating? Is it comfortable? Are there any instances of damp and mold, and so on? And then, yeah, just promoting the appropriate behavior within the customers, and also the team that will be in constant communication with them is quite important overall. And yeah, that brings us to the end of the presentation. In terms of the RISE support, which is the free support that's offered by Turner & Townsend and funded by the department for anyone that's looking to go through the process of applying for any of this funding. There is a self-assessment, which Nikhil would have most likely shared in the chat and will be shared in the emails afterwards. So it's quite important to then just go through that self-assessment so we can then help identify and develop your project from there and give you the necessary support. Yeah, that's all from me. I'll hand over back to Nicole.
Thank you very much, Bhavik. And that was a really insightful session on retrofit interventions and cost caps. So thank you once again for your time and expertise on the same.